audible?
Yes, sir.
Yeah. Hope my screen is also visible. So today we are going to discuss about the natural language processing. So we have completed the machine learning. Then we are moving into the part of artificial intelligence and deep learning. So as part of this artificial intelligence, we are basically going to learn this natural language processing, so which is shortly called as NLP. So what is NLP? Like a written language, phonology. So we know like each language has its own sound, letters. Just a minute. Sorry. Where that? Sorry. So what is NLP is like, we know like each language has its own sound, letters and pronunciation. And morphology, the structure of words, the arrangement of the words is very important in order to carry out the meaning of that sentence. The syntax, how the sequences are structured, like if it is in a paragraph, if there are 4 or 5 sentences, the sentences should be arranged in a manner such a way that it carry out what is the context, what is the information. And semantics, meaning of the strings, so meaning, basically meaning of the words. We know there are some words which has different meanings depending upon the context, so we'll see an example for each and everything. uh, so we have corpus and corpora. Corpus means a body of text usually containing a large number of sentences. So in a very short terminology, corpus is basically a paragraph. Corpora is a collection of text, plural form of corpus. So basically I can say an essay is a corpora. So if it is only one paragraph, that is basically called as corpus. If we have more than one paragraph, that is basically called as corpora. An essay is basically called as corpora. There are three aspects of NLP. One is syntax, semantics, and pragmatics. So which are all very important. Syntax means how sequences are arranged in order to carry out the context. So if we just replace some of the words in a sentence, the entire meaning of the sentence will itself will get varied. The dog bit the boy bit the dog. Just replacing two tokens or words in the sentence, the entire meaning of the words is getting varied. If you guys see the last sentence, bit boy dog the other, it's basically, it's not even arranged. We are not able to capture any kind of information out of it. So syntax is very important. The next is semantics. Semantics is basically, as I already mentioned, there are few words which has a different meaning depending upon the context. So if you guys take the word called interest, Jenna has a strong interest in deep learning, which shows that my wish to do a deep learning course or something. Jenna pays a large amount of interest on his credit card. So which shows this interest is related to the finance domain. The first is related to my own wish. The second is related to the finance domain. So if I wanted to come up with what is the meaning of interest in that particular sentence, I have to basically look the preceding and the succeeding tokens, or otherwise called as the words in that sentence. By seeing the interest token or a word, I cannot come to a conclusion what meaning it derives. So I have to basically, depending on the succeeding and preceding words, I need to come to a conclusion. That is basically called the semantics. Basic semantics means meanings. That's all. Pragmatics. In pragmatics, we have three concepts. One is anaphora, cataphora, and exaphora. Anaphora means, which is basically, first we'll be defining the noun and then we'll be dealing it with the pronoun. So for example, here I have given example, Susan dropped the plate, it shattered loud. So what does that it refers to? As a human, if I read that sentence, I'll be able to come to a conclusion that it refers to the plate. But how system is able to carry out the context? So this is basically called as anaphora. Cataphora. Cataphora means first you're describing the pronoun, then later on telling it as what that particular it is. So because he was very cold, what is that he? That he refers to David. So David put on his code. That is basically called as cataphora. Next is exaphora. Exaphora means which is not something directly present. So this garden hose is better than that one. So basically that one, like we are not sure what that was referred to. So we are basically telling something which is not directly present. So that is basically called as exaphora. So now we are going to basically discuss the concepts of pre-processing techniques of NLP. So whenever you get a text, right, in terms of, say, you can consider as Twitter tweets or in some social media where they put the comments and so on. The data will not be in the straight format for you to analyze it. You have to basically do some pre-processing techniques. Like there will be some hashtags, they'll be pointing out at somebody, there'll be some numbers, some emoticons. Means emoticons means the emojis. So we have to pre-process the data because system will not understand all these things, right? So we need only the information, and people might use some contradictions, like say, uh, I have, means they will write I apostrophe, means a single quote followed by VE, the short form. I see you, see, they instead of SEE they write only C. YOU they write U. For good night they write G. So these are all the contradictions. So these things, as a human, we try to chat with our friends and so on. But how system will able to understand? So for this, we have the pre-processing techniques. The first technique is a tokenization. Tokenization is basically a splitting up sentence into particular individual words. So basically called as tokens. Tokens means if in a sentence, if you have a five words, I am a student. If it is a sentence, I is one token, am is another token, a is another token, and student is another token. If there is a full stop, even that full stop will be considered as one of the token. So we apply tokenization on top of the sentence and we'll get the corresponding tokens. Here we have three categories. One is word tokenized, send tokenized, and custom tokenized. Word tokenized means splitting a sentence into constituent tokens is basically called as word tokenized. Sentence tokenized is if you have a paragraph where you have some 5 to 7 lines or 7 sentences, splitting each sentence out of that paragraph, that is basically called as sentence tokenized. You might be asking how the system is able to do it, sentence tokenize or word tokenize. How it is able to come up with a conclusion that in a sentence, I am a student, I is one token, am is another token. In every language, we follow some delimiter. Means in English, we give spaces between two words. So I'm not sure the other languages how they do is. Even in Tamil, Hindi also we use this delimiter. In Arabic, I think sorry, that Urdu they write from, generally we write from left to right. They write from right to left. So there are a few things are there with respect to each language. So there is a library called NLTK, Natural Language Toolkit Library, which has already a kind of a trained model which has seen an enormous amount of data with respect to English language. Like it has been trained on other languages like Chinese, French, and so on. So let us now consider our example for English. So it has seen an enormous amount of text from Wikipedia and so many textbooks and so on. So now it is a trained model. Now it is able, and right now it is in a position to basically understand the language and split it accordingly. Even if there is a question mark in a paragraph, one of the sentence, that is even basically a separate sentence. You might also ask me if there is a Dr. K. Janardhanan, DR, we'll be using that abbreviation, right? In order to tell that he is a doctorate, right? So in such condition, even a DR will be separated as a separate sentence. K will be a separate sentence. No, nothing like that. Because it has seen enormous amount of text, which has come up this kind of situations where they have trained it. So now it will not behave in such wrong directions. Okay, so this is with respect to sentence tokenize and word tokenize. The third one is a custom tokenization. Custom tokenization is basically you are going to define the tokenization with respect to your own domain specific requirements. See, you're working in some XYZ corporate company. You know we all will be running some test cases or developing an application or whatever we are being immersed with. So say I'm building an I have an application which will be basically will be running some test cases or whatever it is. It will be writing some kind of a logs. Okay. uh, if there is any error, right, it will be writing a logs. So the logs I've designed in such a way that the the alarm raised at 7/7/2025 p.m. is, I might have designed my application such a way that whether it is a critical alarm or a major alarm or a minor alarm. So depending on that, it will be writing that alarm. But the other sentences are going to be the same. The alarm at 7/7/2025 27. So this date can change every day, and the time can change every minute or every second. Like however you have designed your application. For example, if you design to write alarm at every 2 minutes, it will be writing at 2 minutes. If it is 5 minutes, it will be writing at 5 minutes. But the major important information for us is that when it has occurred and what is the alarm. We are not sure about the alarm generated at 11:11. So that string we don't want that string, the alarm generated at. We want which day, what timing, and what is the alarm. With this, I can basically train my model. So if you are sure like how the format of your alarm will be generated, you can basically take this custom tokenization to solve that kind of problems. You can basically define your own tokenization. Like if you're having a big paragraph, okay, and if you wanted to take only the emails out of it, maybe there are some email IDs, some 10-20 email IDs are there, or you have some phone numbers in it, or if you encounter any some numbers 1 2 3 like that, so you can write a custom tokenization in such a way that to extract it. I'll be showing the demo for each and everything whatever I'm discussing today tomorrow, but let us understand the theoretical part first. The next, the text correction. So there is a algorithm called Norwig's algorithm, so which will basically try to help to resolve the spelling mistakes. So and as I already mentioned about this contractions, so you guys can see here we have, so that has been changed to we have. Here we will meet you in project, you has been represented in YOU, we will, so we WILL. So when you guys give an input to ChatGPT, if there are some spelling mistake, it will never say you that Sharon, you have made this mistake, correct the spelling and say that. So how it is able to basically still accept. So what it will do whenever you giving a wrong spelling, it will try to take that spelling, okay, and it will basically go for the calculation of uh, cosine similarity. For example, I'm giving for training. So this is the original spelling. I might have given training like this. Instead of A, I'm giving E. So there is no such terminology in English, at least as per my knowledge. So in such cases, what it will try to do, it will try to with this wrong spelling, whatever the similarity words are there in English vocabulary, it will try to calculate the cosine similarity value. So A dot B divided by modulus of A and modulus of B. So it will be trying to so the value will be ranging from I think -1 to +1, or 0 to 1 you can consider. So what it will try to do, it will try to calculate the cosine similarity between the wrong misspelled word with the other terminologies which are there in the English. So for each word, it will be getting the corresponding cosine similarity value, and it will see the one which has the highest cosine similarity value will be replaced. So in our case, this training is the highest probability value. So this will be replaced with this particular word, because anyway if you calculate the cosine similarity value, obviously this particular word will have the highest probability value, so close to some 0.9. Others might be considering as 0.3 or something. So in such cases, the one which is the highest probability will be replaced by the algorithm. Just a minute. Sorry guys. So next is the stop words. So stop words in every language, there are some specific stop words. If you guys consider in English, we have 196 stop words, which does not constitute much meaning to the sentence. But with respect to in terms of grammatical way, it is important. But which like in the from at like so on so off and like this. There are some stop words in English, like we have 196, which does not carry much meaning to our what to say to our meaning. So we can basically go on ahead and remove those stop words. So that is basically called as stop words. Removing special characters and making the text to lowercase. So we have to basically convert the text either to lowercase, from lowercase to uppercase, or uppercase to lowercase, making all the text to one case. The next is the stemming. Stemming is basically bringing the word to the root form, like for example, running, runs. But for everything, we'll be representing with respect to the tenses. But the root word for that is basically run. From that only will, run, runs, running, everything is been derived. But all for these is the base word is the root word is a run. So stemming, as the name itself indicates, it brings a word to the root form. But one of the disadvantage of stemming is most of the time when it brings a word to the root form, it does not care whether that particular word is part of English vocabulary or not. So if you guys see history and historical, it is bringing to HISTORI, which is basically there is no such vocabulary in English, HISTORI. And finally, and final brings a word to fina, which is not there in the English vocabulary. So it does the process very fast, but the only disadvantage is it will not check whether that particular word is part of English vocabulary. But sometimes it brings the word to the correct format also. But in order to solve this disadvantage, they have come up with other approach called lemmatization. So lemmatization is basically bringing the word to the root from the same approach, but it this lemmatization keeps track of the one thing is whether it is part of English vocabulary, and also it keeps tracks of the POS tag, parts of speech tag. So if you guys see with respect to stemming, the changing has become change, CHANG. There is no such word in English. But with respect to lemmatization, it brought the word to the change, CHANG, which is a meaningful word. Okay. Okay. So these are the pre-processing steps. So first is the tokenization, stop words removal, making the text to lowercase. You can remove the special characters also. You can include it like a hashtag, add exclamatory mark, question mark, and so on. So then you can go for stemming or lemmatization. You can also visualize how you're getting the results with respect to stemming. The same thing you can apply lemmatization, and you can see the difference between your stemming and lemmatization. Okay. Any doubts so far?
No, sir.
Okay. So you guys are recollecting the machine learning. See, I'm not going very fast also, and I'm not taking 1 hour class also every day. I'm taking very small concepts and going very slowly, because you have to guys have to catch up. Else I can continuously take for 1 hour and I can complete the syllabus in very short period of time. But I don't want to do that, because you have to basically learn things a lot. So how is your learning with respect to machine learning? Are you guys referring the recordings or going through it, working out on something? Do you want any Q&A sessions or something like that? You can please feel free. I'll conduct if you guys want Q&A sessions on machine learning. Do you guys want any Q&A sessions on machine learning? Or you guys have any yes, Shweta?
Yes, sir. Event is, if possible, it is okay, sir.
Yeah, can we have it
In
on Friday?
in interview, how which questions will be there like that? Important questions like that.
Yeah, yeah,
Any
I'm ready to conduct. So you guys also need time
one?
to prepare, right? Can I give you
Yeah,
next
yeah, yeah.
Monday deadline?
Okay, okay, sir. If not,
So
ML and AL, you can both at a time. No.
yeah, I can do that. That's what I want you guys to answer it very properly. That's what I, if you
Yeah,
guys
yeah,
want time also, I'll give you.
yeah, yeah. We want time actually.
Yeah, yeah, that's what I'm giving. Like Friday, I'm okay, or we can have it on Monday because I'll give enough
Okay,
time. Do the preparation.
So
okay, okay, sir.
Monday.
Monday, okay, fine.
Yeah,
We'll keep it on
Monday.
Monday. In meantime,
So
we will have
Saturday, Sunday,
Saturday,
we
Sunday
will.
also. You can
Yeah,
go through the recordings and other. But I'll share the Q&A questions. Post, I'll ask the Q&A questions. Then later on, after that test, I'll give the question bank. Not before that.
yeah. Okay, okay.
If I give the question bank, you will be sticking to that and learn all things from there. It's like a theory class, like you guys just memorize and come or something like that. I don't want to do that because there is no use in doing like that. Okay. So guys, take time, please prepare. So we are going to meet another 10 lectures. Okay. So please try to attend all the lectures. And if you guys still have doubts with the machine learning or statistics part, please feel free to ask it and get it clarified. No problem. Even if you ask basic doubts, I'm ready to answer. So don't hesitate or something. You can post it in the WhatsApp chat or to me privately or whatever, however the way you want it. Please utilize it. That's all. That's the only requirement I needed from my side. Okay.
Yes, sir.
Yeah. Okay, guys. Thank you. Bye bye.
Okay. Thank you.
Thank you. I'll share the notes in the group.